From Seattle to Miami, LA to Boston, San Francisco to Washington, D.C., there's no question that the modern metropolis dominates the American landscape. Its urban sprawl rises up out of our amber fields of grain. In nearby New York, we see the culmination of the city system, its skyscrapers continually reaching upward and outward.
While the compact nature of the city life does have its environmental benefits, cities such as New York have their fair share of environmental problems as well. Besides the grime, trash, and crime that often develop in city regions, the vast expanses of concrete, asphalt, and steel also cause several problems. Lack of greenery and natural vegetation can lead to city temperatures being several degrees hotter than those of neighboring suburban areas. Called the heat island effect, this phenomenon can lead to bad air quality and spikes in energy demand.
The lack of permeable surfaces also leads to uncontrolled runoff of rainwater. The sudden surge of water input from sewers during rainstorms causes water treatment plants to go over capacity, sending contaminated water and sewage cascading into the regional watershed.
Over time, these problems can seriously affect not only the health of the natural environment, but people as well.
We have become so disconnected from what really sustains our own lives that it's at our own peril.
Fortunately, there's a new solution. Gardens place stories above the busy streets and subways.
I was overwhelmed by what an elegant technique or approach green roofs really are. I mean, you've got this wasted resource, all these flat rooftops that are exacerbating environmental problems, and here you have an opportunity to turn it into something that people can enjoy either visually or through their activity. And at the same time mitigate the urban heat island effect and retain and detain stormwater, preventing runoff pollution.
The development and implementation of green roofs is one way to help combat the problems associated with asphalt jungles.
Most of the green roofs we've done have been an integrated system, which is sort of like this model. It's installed layer by layer, from the waterproof membrane, the root barrier, the drainage layer, the water retention method, the growing insulation, the growing media, soil replacement alternative, and plants.
There's the idea that a green roof can be accessible. I mean, it's not just a veneer that, hands off. It can be a place that human beings can interact with. So, and that has a whole social quality to it that I feel very strongly about in an urban area where we have so little land. Why aren't we using the roofs as open space?
Many varieties of green roof designs exist, depending on the strength and structure of the roof as well as the accessibility of the roof itself. While shorter alpine plants, usually sedums, are used on more inaccessible or extensive roofs, green roofs designed for access to more people often can have everything from flowers, vines, tomato plants, and in extreme cases, trees.
In addition to sedum and sempervivum, you can get some grasses in there, and you can even, in 4 inches of growing media, grow some flowers and some wildflowers and maybe even a little bit of lettuce if you wanted to. On the other hand, if what you want is tomato plants, you better figure that you're going to have somewhere between 9 and 12 inches to really get some good productivity out of it.
After learning all about the structure of green roofs, we soon found ourselves amazed by their ability to efficiently handle the problems resulting from impervious city surfaces, especially those reducing the heat island effect and preventing excessive stormwater runoff.
Whereas the temperature of black roofs is regularly twice as high as the atmosphere's temperature, green roofs lower both indoor and outdoor temperature. By protecting the roof from temperature flux and ultraviolet rays, Green roofs increase roof life by a factor of 2. Even a 2-inch deep green roof absorbs half of rainfall.
Various tests have been done to demonstrate how it is that a green roof helps improve the temperature. One is that heat is not being reflected back into the atmosphere from a dark surface. And secondly, what a green roof offers is the evapotranspiration, so that in the act of emitting moisture back into the atmosphere, it is then adding a cooling effect. So that's from the heat gain standpoint. Then from the water quality, when we have a storm, all it takes, in fact, is 1/4 of an inch an hour of rain to cause a problem in our wastewater treatment plants. What a green roof can do is water percolates through the soil and it gets all distracted in there, and then it has to flow over this. And the main thing is it takes a certain period of time for the water to percolate through the soil before it gets into the drain.
The rooftops are a really great way to bring biodiversity habitat, stormwater management, the cooling of the urban heat island effect that we create by having all this dark, impervious surface. And we can save energy and try to knock the peak off of, the kind of impacts that we're having.
You don't need to be a scientist to realize all the positive features of green roofs. Just a trip outside on one might be all it takes to convince yourself of their refreshing benefits.
Green roofs will bring nature closer to people and people closer to nature, while at the same time helping us mitigate these impacts that we have because of the way we live, because of our behavior.
Universities have also started to take notice of the benefits of green building development. Princeton University has not only committed to sustainable design in new construction, but has taken extra steps to study it as well.
Green roofs will be installed by September 2008 on new Butler College residential dorms. For the first time, Princeton students will not only be able to enjoy the green roofs and their benefits, but study their impacts on the campus, providing an amazing opportunity for green roof education and research.
Because of the way it's set up, there's a conventional roof right next to the green roof in 2 different buildings. We're just looking at one section of Butler roof, and so they're sort of like mirror images. And we're very lucky to get in on the beginning of the project and be able to put the sensors in while the construction is taking place. So we can compare both the conventional and the green roof side by side. The roof has different layers, both on the conventional roof and the green roof, and they have different properties in terms of storing heat and releasing heat. And so we can put heat flux transducers. And in the green roof, we have a soil moisture probe along with temperature probes. And our plans are to display that on our website, so everyone within the university and students can have access to what's going on minute by minute. So it's a great opportunity for students to get involved.
While green roofs have been around for some time, there's still much potential for additional research. Subjects like plant types, retrofitting existing building roofs, and further analysis of the benefits still need to be explored. Each green roof can be very particular in environment, varying based on climate zone, local bearings, and design specifications.
Hopefully, such hands-on education like the Butler Green Roofs will help spread its knowledge and implementation beyond campus grounds. With rising fuel prices and environmental concerns now on the forefront of American politics and economics, green roof and related green infrastructure are finally getting past prior obstacles.
With the possibility of a future like that, we can all rest a little easier.